we are going to cover completing the square and quadratic formula for this set of notes. So completing the square, not all quadratic formulas can be solved by factoring or the square root property, so we have to use completing the square, the quadratic formula. So we're going to use this example, x squared plus 4x plus 1 equals 0 to demonstrate. With a quick check, you can see it doesn't factor. A times c is 1. There's no factors of 1. They're going to add up to 4. So it does not factor, or it's prime. But that doesn't mean we can't solve it. We just have to figure out another way to do it. So what we do is we add or subtract the constant term to the right side of the equal sign. So that plus 1 gets subtracted and it's minus 1 on the other side. Then I guess the most important part of the equation is the x term. So you want to look at what's in front of the x, that's your b. And we take half of b and we square it and add it to both sides. So b is 4. Half of that would be 2. Half of b squared equals 4. So 4 gets added to both sides, because whatever you do to one side, you have to do the other. And that creates a perfect square trinomial on the left. That x squared plus 4x plus 4 can now be factored to x squared plus, or x plus 2 all squared. And then from there you can use that square root property to finish it. So let's do an example of our own. 27a is x squared minus 3x minus 5 equals 0. I add 5 to both sides. All right, now I want to look at my b. My b is negative 3. Half of b, actually this reminds me that I need to do part b first. Let's come back to that one. Part b, it's already, the 13 already got added to both sides. Our b here, so the problem is x squared minus 6x equals 13. b is equal to negative 6. Half of b would be negative 3. Half of b squared equals 9. So that's what gets added to both sides. We get x squared minus 6x plus 9. And by doing that, it creates that perfect square trinomial of x plus 3 squared. All right, I added 9 to the other side, so now it's equal to 22. Take the square root of both sides. And remember then that gives us a plus or minus the square root of 22. Subtract 3. So x is equal to negative 3 plus or minus the square root of 22. And I can't simplify that anymore. All right, that's the square, that's the completing the square process. Oh yeah, let's come back to part A. So I stopped here because you end up with that fraction, and I didn't want to start off right away with a fraction. But you would get, our b is negative 3. Half of that would be negative 3 halves. Half of it squared, and I think it helps to write these notes on the side, because you'll sometimes refer back to them for the next step. So I'm adding 9/4, x squared minus 3x plus 9/4 equals 5 plus 9/4. So break out the calculator for that. Now, how do I know what that's a perfect square trinomial of? Use your half b. So half b is negative 3 halves. That's what's going to be there. And I put 5 plus 9/4 in the calculator, and I got 29/4. All right, take the square root of both sides. So x minus 3 halves is equal to plus or minus. All right, so no, we know that the square root of 4 is just 2, so I can take that out and then add 3 halves over. So x is equal to 3 halves plus or minus the square root of 29 over 2. That looks terrible. Let me write it down here. It's not a pretty answer, but it's correct. Checking it is not fun. All right, last page. The quadratic formula. This is my favorite way to solve it. It'll solve any quadratic equation that's solvable. All right, so the quadratic formula is on the previous page, so you guys can open to that. And I just start writing it out. So it's x squared plus 5x plus 1 equals 0. You have to know what a, b, and c are. So it's going to be negative b, which is negative 5, plus or minus the square root of b squared, so it's 25, minus 4 times a times c. And I just put the numbers in as I'm saying the a's and the b's and the c's, all over 2a. So start by simplifying the radical. So it's just 25 minus 4, which is 21. And we're kind of lucky here because you can't simplify that anymore. So that's just your answer. Sometimes these are easier than by factoring because you put everything in and it doesn't simplify. So you're just done. Part B, x squared plus x plus 2 equals 0. So x is equal to negative b, which is negative 1, plus or minus the square root of 1 squared minus 4 times 1 times 2, all over 2. All right, so if we start by simplifying the radical, we get 1 minus 8. And that's going to be a negative 7. So I, meant to actually do complex numbers with you guys first, but that's okay. So that negative 7 can be written as negative 1 times 7. And the square root of negative 1, you get a little preview, is I. So we don't want to leave that negative in there. Instead, we just write it as negative 1 plus or minus the square root of 7 times I, all over 2. All right, that'll hopefully make more sense when we talk about complex numbers, which will be in the next video. And then last thing is the discriminant, that part of the quadratic equation that's underneath the square root, the b squared minus 4ac. When you do that, and it equals 0, then you have one rational solution. If it's greater than 0, you get two rational solutions. If it's greater than 0 and a perfect square, you get two rational. If it's not a perfect square, you get two irrational solutions. And that's what happened with this one. Sorry, no, that's not what happened. It's the next one. Ours was less than 0 or negative, so we get two complex solutions. That's what happens here. And there's two because there's a plus and a minus. So that's the discriminant, and I just wanted to mention it. I'm not sure if there's any actual homework problems on that or not, but anyway, if you have any questions on this, make sure that you've jotted them down, and we'll go over them in class.